Good evening. Today we'll be covering the last section in Chapter 11 that we cover at Maricosta College. It is 11.4, Equations which are quadratic in form, from Blitzer's Introductory and Intermediate Algebra for College Students. My name is Professor Shannon Gracie, and I will be your host. Okay, here we go. Why don't you guys go ahead and warm up? We're going to just practice solving equations and simplify radicals or rationalized denominators when if you come across those situations. So pause the movie and warm it up. Good luck. All right, let's see how you did. So for the first one, I'm going to go ahead and get 0 on one side by subtracting 3 from both sides, and then we'll have an equation that is in the proper format. It's quadratic and it has 0 on one side. So our A is -5, our B is 1, and our C is -3. I'll go ahead and use the quadratic formula. So x will be the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So x will be -1 plus or minus, under that square root we've got 3 minuses, so we'd be subtracting that quantity. So do you see that 4 times 5 times 3 is 60. 1 minus 60 is -59, and that's all over -10. So x will be -1 plus or minus root 59, and then I, because of the negative, the root -1, over -10. This is a complex number, so we'll go ahead and write it as separate fractions. So do you see it'll end up being +1/10, and then we'll just put plus or minus. I know there's a -10 down here, but that'll be wrapped up in that plus or minus, so you don't have to worry about it in this case. And then we'll get root 59 over 10 times I. And we'll go ahead and put that in the roster notation, the set notation. And we're all set. How'd you do on that guy? Awesome. All right, so for part B, see how you're doing. Again, I want to get all the terms on one side and 0 on the other. So when I subtract x from both sides and add 6, I get this equation here that is equivalent. My A is 1, my B is -1, and my C is 6. So x will be the opposite of -1 plus or minus the square root of -1 squared minus 4 times A, which is 1, times B, which is 6, and that's all over 2 times a, which is 1. So x will be +1 plus or minus. Let's see, it'll be 1 minus 24, so we'll get -23 under the radical over 2. So x will be 1 plus or minus root 23 times I, all over 2. Then I'll go ahead and break it into 2 fractions to have it be in the form for a complex number. And we're all set. How'd we do on that guy? Great. Okay. So today we're going to be doing a lot of, problem solving. Equations which are quadratic in form is one that can be expressed as a quadratic equation using an appropriate substitution. In an equation that's quadratic in form, the variable factor in one term is the square of the variable factor in the other term. So often, you're going to look at the variable that's with your second term, right? The third term is a constant. So by letting u equal the variable factor that reappears squared, a quadratic equation in u will result. So you'll use your same skills. You can solve by factoring, using the quadratic formula, completing the square, and you just solve for u. The main trick is after you solve for u, you got to go back to your substitution and solve for x, right? So you'll be, or whatever your original variable was. So the variable in the original equation. Okay. So this first example, the trick is you got to see if you can write, something squared plus or minus something to the 1 plus a constant is 0. So like I was saying, a lot of times the clue is in the middle term. See this x squared in the middle? So try to rewrite this. Can we rewrite this guy as x squared squared? Is that x to the 4th? You got it, it is. So we'll just look at it like this. And then we're going to say, oh, our substitution is going to be u equals x squared. So here is our u. So we're going to put a u wherever we see an x squared, and then it's just going to look friendlier. Doesn't this look like what we were solving in the, similar to the warm-up problems? In fact, this one is easier because the warm-up problems we needed to use, the quadratic formula. This one is factorable. We've got an overall product of positive 36, and so we need two numbers that'll add up, that'll have the negative signs and add up to 13. And so if we have u minus 9 times u minus 4, that's going to work out. So then we use the 0 property. And we'll have u is equal to 9 or u is equal to 4. Now here's the trick. You got to go back because we don't want u, we want x. Okay? So what we're going to do is we're going to come over here. We got two results for u. Okay? So this was our substitution. So remember we got u was 9, so we get 9 as x squared, or we get 4 is x squared, and we solve the resulting equations. So if we square root both sides, and remember this is what we got for u, over here, so we just plug them in. So when we solve them, do you see we'll get plus or minus 3 is x, or plus or minus 2 is x. And so I'll leave you to check this, this in the original equation, that we'll have 4 solutions for this guy. Which makes sense because it's a fourth degree equation. It doesn't always have, 4 distinct solutions, but it will if you're in the complex numbers. You'll get 4 always. All right, so here we go. I'm going to let you pause the movie and try B. It's going to be very similar than it was to the other equation. So good luck. All right, let's see how you did. We need to first get the 5 on one side. And then again, do you see that we can write this as x squared squared plus 4 times x squared minus 5 is 0. So our substitution again is u equals x squared and so if we write it like that, we get a relatively easy equation to solve. Again, here's our substitution. So this guy actually is also able to be factored. U plus 5 times u minus 1 is 0. If you're not comfortable with factoring, you can use the quadratic equation on here, and that's fine. So u plus 5 is 0, or u minus 1 is 0. U is negative 5, or u is 1. So again, these were answers that we got for u. So now we need to go and we need to solve for x. So we get negative 5 is x squared, or 1 is x squared. So these are the answers we got for u, and now we need to find what x is. So if I square root both sides, I will get, be careful that it's a negative under the radical, so we're going to get plus or minus root 5 times I equals x, or plus or minus 1 is equal to x. So again, we'll have four solutions. And I'll leave you to check that guy too. All right, so part C, let's see what we've got going on. Part C, again, let's look at that middle term and see if it works out. So you got to think to yourself, is root x squared equal to x? And yes, it is. So that's going to be your substitution. U is equal to root x. So that'll give us u squared plus u minus 6 is 0. And we'll have, this is also something we can factor. U plus 3 times u minus 2 is 0. So u plus 3 is 0, or u minus 2 is 0. U is negative 3, or u is positive 2. And then we've got our values for u. So we come back over here. This was our substitution. So we say, oh, okay, negative 3 is root x, or 2 is root x. Now, whenever there's a square root in the equation, I do a formal check, because these often you'll get an extraneous result if you remember from, I think it was, what was it, chapter 9 or 10? I guess it was chapter 10 we did the radicals. So here we go. This was what we had gotten, for u, the two possibles. So when I have to, this time I have to square, I'll do it in green. I'll square both sides of each of these equations in order to get x to the 1 power. So I either get x is 9 or x is 4. So now let's go ahead and we'll check. So x is 9. that would be 9 plus the square root of 9 minus 6. Is that equal to 0? So 9 plus 3 minus 6, is that equal to 0? No, 6 is not equal to 0. This guy will throw out, it's an extraneous result. And then we'll check x is 4. So we'll get 4 plus the square root of 4 minus 6. Is that equal to 0? 4 plus 2 minus 6. Is that equal to 0? 0 does indeed equal to 0, so that one checks. So we only get one result this time. X is 4, and we're done. Okay. So, a couple more problems. This one is kind of done up in a bow for us. Do you see we've got something squared and the same something to the 1 power? So in this case, u is just going to be x plus 3. All right? So we'll have u squared plus 7 times u minus 18 is 0. And this is what we made u be. Okay, so this, again, we lucked out. This can factor u plus 9 times u minus 2 equal to 0. So u plus 9 is 0, or u minus 2 is 0. Gives us u is negative 9, or u is 2. So coming back over here and plugging in what we got negative 9 is x plus 3, or 2 is x plus 3. And these are what we had found for u. And now we just need to isolate x. So if I subtract 3 from both sides, I get negative 12 is x. And on this one, subtracting 3 from both sides yields negative 1 is x. And I'll leave the check on that guy to you. But we get our result of negative 12 and negative 1. Okay. And this will be the last problem of the lecture here. We have x to the negative 2 minus 6 times x to the negative 1 equals negative 4. So let's go ahead and first get that, add 4 to both sides. And then we'll have, what we look at that middle term, and what you got to do is see if I square that middle term, is that going to give me this guy up here? So if I square x to the negative 1, does that give me x to the negative 2? And remember, when you raise a power to a power, you multiply. So we're good. Well, we have our substitution. So in this case, we get our substitution as u equals x to the minus 1. Now that's equivalent to u equals 1 over x. And you know, while we're at it, why don't we go ahead and isolate x, because we're going to need to eventually. So do you see, if I do a little bit of maneuvering, if I multiply x by both sides and then divide by u, I get x is 1 over u. So then we're going to have u squared minus 6u plus 4 is 0. And this was our substitution. So we're going to be putting our u's in right there when we're all done. And that was our initial, and that last one is what we'll be using after we solve this. Now this one, we need to use the quadratic formula. So u is the opposite of negative 6 plus or minus the square root of negative 6 squared minus 4 times a, which is 1, times c, which is positive 4, all over 2 times a, which is 1. So u equals 6 plus or minus 36 minus 16 is 20, so we'll get root 20 over 2. So we'll have u equals 6 plus or minus 20 has a perfect square in there. 4 times 5 is 20. Square root of 4 is 2. So I get 2 root 5 when I simplify that radical of root 20. And then here, do you see that if I factored out a 2, I'd get 3 plus or minus root 5 over 2, and I can actually divide out this 2. So u will equal to 3 plus or minus root 5. So coming back over here, remember we have, so x is equal to 1 over 3 plus root 5, or x is equal to 1 over 3 minus root 5. Make that a little more compact. And so these were the two values I got for u. So now remember, they want us to rationalize. So I've got to multiply by the conjugate. So the first one, the conjugate, will be the 3 minus root 5. So for the first result, I get 3 minus root 5 over 3 squared minus root 5 squared. So x is equal to 3 minus root 5 over 9 minus 5 is 4. So over here, it will get a similar result. Multiply both sides by 3 plus root 5, or not both sides, numerator and denominator by 3 plus root 5. And then we'll have x is equal to 3 plus root 5 over 3 squared minus root 5 squared. So x is 3 plus root 5 over 4. So our result, we can do it as plus or minus. We get 3 plus or minus root 5 over 4. And there you have it. I think we are done for today. So have a fabulous evening, and don't forget to do some items from the problem set. Bye.